Good afternoon, team again, code members and the teachers, whoever you are connected. I've seen some concerns that somebody's asking whether we are going on. Yes, we are going on. We were just a bit delayed because of the setup. Today's setup is a bit troublesome because we are going to use probably water and electronics sometimes become funny. So we were just taking sometimes ensuring that the water is well placed in that. Thank you very much and welcome. Today we are going to talk about we're going to do a simple project for water sensor, and probably from here you can get inspired to come up with your own project around water and stuff like that. And today I think we are going to look at again another sensor which is called water sensor, as you have heard about it, and we want to see what are some of the possible projects you can do with the water sensor around probably in your community. It's not necessarily water sensor as much as we put the word water, but it can be for any liquid sensor. Let us talk about liquid sensor. Appropriately, we would be using it for liquid, for sensing liquids. Great. I think maybe without taking much of your time, probably it's good to just recap on what we did yesterday. I think, and the other time, I mean, the previous lesson, we were more focused on various actuators that were there. I think we talked more, and of course, you can remember we were talking about the servo, and the servo motor, a very good motor. We said that the servo motors are very good, especially when you want to do a lot of precision. You want to have something turning to a very precise precision. Unlike the other motors, this motor is very, very good. It's the one that is used probably in areas where we have something like probably robotics, in weather stations, or some kind of thing that are turning, probably even in the construction industry or in the industries. You'll find the arm turning at a particular degrees to pick another object and take. For example, in the car industry, as you can see, when the car is being assembled by the machine, the Internet of Things within the industry, you'll see the car picking that. And I think maybe you must really know that the servo is a very powerful object and a very powerful actuator, and you really need, we talked about all this yesterday, I mean, in the previous lesson, and we said it is a must. You have to consider the speed and the torque. I think all that is good. I'm just going back into that same presentation, and it is worth noting that servo motors are very, very important, especially because it is possible you can get one that turns 270 degrees, or you can get one that only goes for probably 90, or it's continuous. There's one that rotates continuously. Great. I think probably it's just fair to have a look at some. I'm looking at if at all we can get a small or a short video where we can be able to showcase what really happens with servo, especially some of where servo motor has been used. So I want you to watch this video shortly and just see how some of the 10 best projects around the world around servo. I'll be probably talking within, and so that you're able to see. So number 10. So I'll move it very fast. Arduino on games. In the games, I think you can see what that is done by servo motor. That's where the motor is doing. You see, it's counting stacks. That is basically the servo motor doing that. So you can see the precise kind of what we're talking about. The precise way it is turning to make those precise rotation. Even that is a project again. Probably getting again is the piano tiles. You can see it's basically those are motors moving, and it's not any other motor but just the servo motor. Probably another project would be very fast. say number 9, Arduino servo mechanism. And look at that, which is taking some water and turning and bringing and pushing the bubble. So see how it is very, very effective. So you can make such a thing. But I think for us, we have so many problems. So you may not be looking for something that is turning. Look at that, picking some rubbish and putting on top of some can. Just picking and collecting and putting there. All that has been done by the servo. So you see the servo motor is the one working. You can decide to use servo and potentiometer. And when you're using servo and the potentiometer, so you can see what the servo and the potentiometer can be able to do. So I'll leave the link of this video in the description so that you're able to look at it later, so at least you learn more about it. Then probably we have in number 8, you can see these are some of the attempts that have been done by students. In case you are to come up with a solar-based tracker, solar panel, which tracks the sun around. When you're moving, it also moves. So you see everything down at on the basically you find that on the ground, just at the hook there, basically the servo motor. Again, look at that. That is all about sun following solar, into the solar power panels are not left without being attended. So that is very important. Then look at the panorama robot that can take photos around without you struggling. So that is very important. Always that also in your during your time. Those are some of the projects that have been done by Sabo. Even writing your name. And this one, they're just using part of Sabo and copyright old computers. Some of the project number 5 that uh, again Sabo again doing what it does. The pattern is pushed. What it does is just take the chalk and arrange it in the stack. Take it back to the stack, comes back and picks the other one. Others, you can see the servo. Yes, servo. I don't know whether it's very here also the servo. You can based on the servo motor here on not saying maybe where you can see all that can have everything can have motor. So you can imagine how many it's the way you support and so it is important that all this and all this part, but and it higher if robotic vehicle or something going around. But when it comes to precise movement like this, we prefer the servo. So you can see Arduino is on top, and definitely the rest of the part just a servo motor. Great. That is same. I can see that kind of robot moves, gets an obstacle, takes it, and it uses level this and get sending character down, then wait it knows is so we get the by the way very Okay, number one, this one that plays chess. Again, this this is the project. You can see that basically we here there's a lot of the ultrasound. There's an ultrasound distance detector, and then the servo motor is of course connected to the arm so that the robot is able to collect whatever stuff it's supposed to collect. So that is just to crown the servo motor project, the servo motor as the actuator, the one we were talking about yesterday. So you are free to move and do something with the servo. You can remember it's about the speed and also about the torque. So the speed is how it moves very fast, and then the torque, of course, the weight, the amount of weight it's going to bear. And this one will really help you know where are we going to put that thing that is going to carry. If it's supposed to carry something, then you're looking at it in terms of where do I put it? If I fix it here, then it's able to carry up to 10 kg. But because I know most of our projects may not go beyond 10 kg, there's no problem fixing it somewhere there. So please find time and look again on servo. They come in various sizes. There's the small one, which is the G9, and you can even find this one. These two, apparently, they are just probably the same. And then we have this one, it's a bit big, and this one we're calling it full rotation. It rotates round. It can go continuously, continuous rotation. In case you want something to rotate continuously, like for example, maybe a gate rotating and then stopping as you open, then you think about that. But again, I think we talked about the other kind of motor, stepper motor. Remember, we talked about the stepper motor last time. So, but this one we're talking about the servo motor. Stepper motor is also awesome, but possibly for some projects. But this one is for this kind of project that I've really shown you. So today, I think we want to look at another sensor, and possibly if time will allow us, we will go straight to the. So today we're going to talk about the water sensor or liquid sensor, and if time allows us, we are going to get to probably the buzzer so that we get the sound or something like that. So we're going to do a very simple project. So majorly today will be basically just coding. So let us code, and then we will want to receive your questions as we move on. Great. So think the many gadgets we are looking at. The one today we are looking to check on is this one. We are calling it the water sensor, the water level sensor. You will always find it in the Arduino kit. If it is not there, I guess this comes with the Arduino kit, definitely. The basic Arduino kit, this one has to come with it. And this is how it looks like. Maybe other photos along the line, we can get more photos online. And when I think some of the photos that I've been able to get are this one from GeekPub. It's called water sensor. You can imagine, you can see the way it's written here. So it's water sensor. And I want to call your attention to the kind of the pins. It has 3 pins. And the first pin is, of course, the signal pin. This is the one that you put to one of the Arduino, and possibly, and we are talking about the analog pin, because remember, water sensor it's not going to give us numbers, or it's going to give us constant numbers of either 1 or 0. It is levels, different levels. It is either full or medium or half full or very full, whatever full you want to talk about, or maybe it is empty. So if you are testing water inside probably a cup or some stuff like that, you want to see whether that water is full or that water is not full. So it's good to check on that and probably look at that signal. This is the one that you're going to use So because of the range of values that this signal is going to give, we tend to look at it as more of an analog pin, and therefore we are going to fix it to any of the analog pins. Then the others, of course, the minus stands for the ground, and then this for the voltage coming in. This one you have to fix, if possible, put it in the 5 volt in your Arduino, and this other one put it on the ground of the Arduino, and we have several grounds on the Arduino. So I think this is very clear. Maybe if there's another picture, let us see the connection, how it would look like. Yes, that is the connection. And this is probably the way we want it. So we will use pin A5 in the Arduino, and also we'll use the ground pin and the 5 volt pin. Remember, this is our breadboard, so ensure you have connected. If you have this, I can wait for you to connect. If anybody can try, so that before we go to coding, then we are quite aware of how we want to work. So remember, the same way we said, the positive will go to the negative, will go to the ground, the plus here will go to 5 volts, and the signal pin will go to the signal pin output, which is A5. I want to give you 1 minute. If you have this kind of thing, you can be able to set up this way. So we can again can go on and let us have a look at our tools for today, and I think you can be able to see. I'm trying to work on the camera so that we are able to get it right. Yes, so here we have the water sensor, and you can see it's already connected to the 3 pins. So we have connected the 3 pins. As we have said, there's the S and probably and all that, and the way we talked about the S minus and the plus sign there, meaning therefore we said that using the Arduino, we have to think about now ensuring that the Arduino is we have just decided to connect the Arduino to the breadboard here. If you can be able to get that, the breadboard is here, although it's white, so the background needed to be something else, but no problem. Okay, I can put something maybe blue background so that at least you can see the difference here on the box. Great. So we want to see whether we can be able to measure some water levels using the Arduino and probably get it done. Yes, I think that is not bad. Great. All right. So you can see we have connected from positive, from 5 volts on the Arduino ground. We have put it on the red line, on the blue line. That is to say that is the ground. Ground, yes, ground, we put it on the blue line, and then the 5 volts, we put it on the red line. So, okay, now this is our water sensor. Here it is. So we want to also connect. We said the data, which is in our case, the data one, which is in our case here, we've used the white one. We are going to use A5, pin A5. Then, of course, it's always advisable that you ground your sensors, your components first, so that you never know, you may be able to save them. So probably this will go to the ground. Yes, I hope so. And this should go to the where is the ground? Yes. This should be able to go to the, if it does not light, you need to check on the connections. Yeah, these ones are not well connected. All right, so where are we? Okay. Correct. So if the connections are good, you will see it lighting. You'll see the light here. There's a small LED that is lighting there. So you're able to see that. So I think the connection is good. Now let us go to code this. And as usual, we will get a new Arduino. And let me share this so that you're able to see on the screen. Again, let us code. Let us just code this. Let me send it again so that you get it. So that is how we've done the connections so far. If you have not done it, kindly ensure you do it like that. And then now the coding will just begin shortly. The coding is here. This is the sketch. In our sketch, we have, as usual, the 2 sections. The void, we talked about this, and the setup and the loop section. So what comes before the setup? We said good practice demands that you declare a variable, or you initialize whatever thing you want to use quickly there. Let me go ahead, and now we said we are going to declare this using int as an int variable and or an integer, Doesn't matter. Again, here we'll say this int will be, we call it water sensor, because we are not expecting, we are not going to work with levels of 1.2 or whatever. We just want to see the level in terms of 0. The level, in fact, of the water sensor goes from 0 to almost 1,000. Remember, we are talking about analog devices giving signals between 0 to 20, 13, whatever. I think I'll be able to give you back that. So that is the numbers, and they're basically integers. They don't come in probably in floats or decimal or whatever. They're only whole numbers. So water sensor is our integer, and we say this water sensor, we have hooked it in pin A5. I think we talked about that shortly. Sorry for the water sensor. We have hooked it in pin A5, right? Pin A5. Say, okay. Let me just put, so A5. Put it in A5. We say like that, and then once the next thing is, of course, as usual, we need to put pin mode. You'll find others don't do this, but it is the best practice. You have to set up the mode of the pin. So the pin we are talking about, which is the one for water sensor, or A5, what do we want the pin to do for us? And we call it, because we have already called it up there, water sensor pin. Now it's no longer pin A5. It is now pin which is called water sensor. What do we want it to become? Put a comma. We want it to be an input, because it's going to read values from outside, from the water, bringing in. It's going to give us the analog values, right? So that is all. Then what do we do now? We now start reading those values. So what value are we looking for? We are looking for the water levels. What are the levels? The level can be 1, can be 0, can be 2, can be 300, can be 400, whichever level. So again, we need now to have probably another integer here called water level. So I'll call this water level. Water level here, and water level. Sorry, that bracket is not needed. Just an int called water level, and I'm going to say this is going to take the values from. Remember this analog read, because as it is going to be read from the pin, then it should be able to give us. Why are we having the E? Oh, sorry. So when you see it doesn't change, it means there's some typing errors. And then whatever is in the analog read is in the pin A5. And what is in pin A5? It is water sensor. So we are going to read what signals are coming through this A5, which is, we had already said it is water sensor. Okay. Water sensor. Great. So that is it. So we are good to go. And then how do we know? So already, if at all we even send this, we even save this, then we can save our project and call it water sensor test. Right, I'm just saving it. Then once we have saved it, if we are to push this to the Arduino, it will go. And let us try pushing it by this. Of course, you know the next one, which is to upload. When you are uploading, or rather we are verified definitely, and now can upload, it says done uploading, meaning there was no error. We've really done a good job. Is it working? Yes, it is working. Very well. Very well. How can we know that it's working? Well, we can't know unless either we hook this to some sort of a monitor or display. But because the process of fixing a display, now I don't want to confuse you with the already what we are doing today is water sensor, then we are going to make use of the internal monitor. So Arduino software comes with an internal monitor, which is called serial monitor. If you look at the corner, you'll find something like a glass at the corner. I will be showing you shortly. That is serial monitor. Or you go to tools and you're able to get serial monitor. The shortcut is Control-Shift-M. So you see, if I open the serial monitor, you'll find something is happening. Probably it's reading, but there's nothing happening, so we cannot be able to see. So unless we tell this serial monitor to display for us what is really happening in the background that we cannot be able to see. And how do we enable this serial monitor? This is a very good tool that comes with Arduino software to enable you to be able to monitor what is happening. Because you see the code has been written, we have already uploaded it to the water sensor, but we are not able to say whether this water is sensing or not. Even if you were to put this in a water, even if we were to put the water sensor in the water inside, probably dip it in the water, we may not be able to tell what is happening unless we have hooked, or we can use external display the way we say the LCD display, the 1602 display, which also comes with the Arduino kit. So we can use that, but if not, even before going there, we can utilize this particular tool that come with Arduino. So how do we initialize? How do we make this start working? What we do is we go to the setup. So we set it up. We start probably setting it up at this particular level and saying serial, because it's called serial monitor. And that is the way the name has been typed. If you look at it in the tools, you can find it is serial. So you see it is serial, it is capital S. So I'm just typing it the way it is. So, and I don't need to put serial, so we can say serial.println. We use this print line. Print in line, I mean each and every line. What do you want to print? We want you to print something, but it's not going to print. Oh, sorry, this is where we start. It's at the setup. At the setup, first we just saying we want it to begin. So it starts at the setup. When you are starting, it begins, and then it begins and starts moving at an interval of 9. We usually use that is you just need to type the same number because the interval of 9,600, so that at least it keeps writing at that level. So it picks whatever thing it will be doing and is writing. So that is what you need to put at the setup. And then another thing now, for you to be able to see that it is working, you have to now have it work here during the loop inside your code. And again, just write serial.print. If you don't put it capital, it won't really serial.print line, because now you want it to print something. Print line, there's no L, it's just like that. And there's I here, so print, okay? Yeah, so when it turns, it means it's correct. What do you want to print? Now you pass in what you really want to print, which is the water level. Remember, this is what we are talking about. This is what we want to print. If it is checking the water level, it will be able to print here. It's called water level. That's what we want it to print. And if we save or verify, it is okay. Then we upload, it is okay. Now we can look at what is happening behind, and we can see that it has printed. It is printing very fast, very fast, very fast. We are not able to see. Let us slow down the speed at which it is printing the water level by only adding maybe a delay here. Let us put delay. And again, remember delay we said is in milliseconds. Can we put 2000 so that after 2 seconds it prints? So it's like this one is just continuously. I mean, the water sensor is continuously sensing, but the printing is being done after it keeps checking the values that are in water sensor and displayed to us in the monitor. Great. So if now we verify our code and upload the code, and open again serial monitor, we'll see now it opens. It is 0 because there's no water. There's nothing in the water, so it's going to become 0. But the moment I put some water, for example, I have here probably a glass of water. The moment I fix in some water like this, the reading changes. 199, I dip it further. 259, I dip it further. 269, I dip it further. 282, I put it further. Somewhere like that. So you see the water level and then dropping again back to 26, to 20. The water level keeps dropping. 16. So because I'm removing the water sensor from the water, so you can be able to see that one happening in real time. So if I wipe it out completely, it goes back to 0. So there's no more water. So you see, it's very important. Now let me show you the thing in action. Let me push the camera so that you're able to see it now in action. Great. I will be pushing in the camera, and so that you're able to see it now. Perfect. So camera on. Great. And let me just put this one side. So this one, okay, here. Oh, yeah. It's not here. Okay, good. So no problem. At least you're able to see something. I was just trying to fix out whether I can be able to show both, but not now. So this is the water sensor. So when we dip it in the sensor like this, it will always show the difference. The numbers will change. And let me show you that screen as I also dip it at the same time. Let me send this to live so that you're able to see it properly. So at the moment, if I wipe the water sensor with the tissue, like I'm wiping, so you can see the numbers have gone to 0. You can see the numbers have gone to 0. But the moment I now dip, I'm dipping the water sensor in the water. So I dip it in that glass of water like this, and all of a sudden, you can see the values are changing to 2022. If I dip it further, the values are changing to 262 and stuff like that. So what can you really do with the water sensor? It's happening. It's doing amazingly. You are able to count and get this. Kindly let me have questions. I've seen a question that just come in. Let me try and answer the question. It says, can this monitor the amount of water used by each household? Yes. Yeah, let me put the question so that everybody sees the question. Kindly have a look at the Q&A section so that you are able to look at the questions that we are now answering based on the water level sensor, water sensor. So we are saying, Christine is saying, all right, can this monitor the amount of water used in each household? Yes, it can, and it's very possible. You can be able to get that. If your project is around that, it's good. It's a very good tool to be able to monitor whether the water is in the tank, the water is finished, any kind of unnecessary spillage. You can be able to capture any place which is not meant to be wet, and yet there's water going there. Now this is the one that you trap those waters because you're able to sense, and they are very, 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 very accurate. One thing we love with Arduino sensors, they are very, very accurate because they really give the industry the way it is, because we are expecting these young people using it to be able to come up with projects that are real world, that it's not about mimicking, it's just real world. Christine again asks another question. Can I be able to remotely turn off the water from a particular house when I am away from the home? Oh yes, you can really do that, because you can always look at the water. Even using the water level sensor, you can be able to ascertain the number, where the water has reached. If the water is very far and probably it's almost getting full, you can be able to tell that when it goes to 152, you know, probably you'll have fixed in most cases, the sensor is fixed maybe to the wall, not necessarily down under, because you don't want it to be a must. So you just pick it to the wall, and then you read those, you keep reading. So when you add water, for example, if this one is fixed to this particular part as the wall, and when somebody adds the water and it continues, you can always look at, and I want us to demonstrate that. So let me just put, now it's there, it's saying 14. So let me put it like this, or maybe up to that. No, or maybe just here. So it's saying 180. Okay. If I had another thing and probably added water, I'm just adding more water, and you can now see the level moving from 100 to 200, you see, and it keeps on going. So yes, you can do a lot with it. So you can decide that once it reaches a particular level, something should happen. Again, the use of if, the if statement. If it reaches probably the level 200, do something. Maybe put on the buzzer, create a warning, or probably send a message. Send a message in my phone. Now that one, you need again another tool, especially the SMS module, so that you are able to get the messages and you send to your own phone. And then you can even use that to turn on or turn off the water taps. And I think maybe it's very possible. Yes, we have said that. I think I was showing you, just wanted to show you the module that is particularly used for pump, so that you can be able to control the pump from wherever place you are, the water pump. So yes, it can be done. Good. So it's still there. So when we remove it completely and put it aside, the values will start dropping. The value will start going down and down and down. As you can see, the values are going down because it is drying bit by bit. Right, it's moving away from the water. So once we've moved the water completely, you'll see the values getting to 0. Right, getting closer, 70, then probably then it gets to 0, and then there's nothing. There's no water in the sensor again. So that's how our wonderful sensor works. I don't know whether we have anything today, again, more than that, because I really wanted us to try to even to play around with the buzzer. So probably if the water reaches a particular level, then we should get a warning, and chui, 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 your water is full, the tank should not burst. So imagine areas where you can use the water level sensor. And look at the codes. Codes are very few. We have used just very little code, and we are doing amazingly great. So in terms of display, you can display, and this thing will go on because it's a loop, it's forever loop. It will go on just reading, unless I disconnect everything. It will keep reading, and after 2 seconds, displaying whatever thing it's reading. I'll want to give some times for breaks. I mean, for questions, because of course, break, we had already gone for break. Let's do some questions, if at all anybody has any question, so that we are able to I've just returned the sensor back to the water. Let me just, I wish the water was having a different color so that we are able to get it. Yeah, having thrown it there, the value is 305, and because it is just the same water, probably it will just get to a particular level because it was already in the water before. So yeah, so apparently it is just between 300 and 301 and 299. That is where the level is. So you want to know the level. So you see right now the meaning of this 300, they may not really have a lot of meaning because again, remember you're just picking the analog signal. That is how it is. I don't know whether this is 200 meters, 200 kilometers, 200 millimeters and stuff like that. Remember analog that's how the voltage is brought in, and therefore it is upon us, if we want to get meaningful data from here, either we can use it the way it is or probably get some meaningful data that would probably make it better. For example, we can change this, and I want to take just quite of your time to change this to something. Let the camera will be there, and we'll want to see what else can we do with this data so that let me just move the video so that you don't have the video. So in 2 minutes, we can do something closer, making the code even look a bit better or more meaningful. For example, looking at the water level and giving it probably, we can add some if here, and then we tell it, for example, look at the water level at the loop section here. Then we have known what the water level is all. The interval is whatever there. So instead of just printing the water level, we wanted to print something meaningful. And this something meaningful would be something like that, that if, for example, if the water level, let's say, if water level, remember we have something called water level, the integer here, a variable called water level. If water level is probably minus, let's say it's less than 100, less than or equal to 100. No, let's just put less than 100. Let us imagine that if the water level is less than 100, then what should happen? Probably the print line here should not just be print line, but it should be print what? Print, maybe we want you to print that instead of just putting water, we can just print now a text. But now because we don't have this, we just have to quote, give a quotation. Water level is, okay, now let us, because for a word, for somebody's eyes, water level is, and then we write empty, like that. And we close again, because we just how we want it to be written, water level, empty. And then, of course, that is good enough. That's how we'd want it to print. Now let me put it, and then delay a bit, correct. So let me just repeat this because again, but now there's something, I didn't use the right one there. So that one comes, and remember this is something, and then we can put else if again, what else if, then probably, let me just copy paste this so that at least we have the same thing here, else if, and then I copy and probably put it here so that if water level is less or equal to probably 300, it's not less, it's more. It is more because it's more than 100. more than 100, and it is less, because so that we have different values, and that's how we put and 100 and water level is less than, because again 300, less than or equal to 300. Then what do you want it to say? Again, bracket. Now you see that if it is more than 100 but less than 300, what do you want to say? Probably want to say medium or low. The water level is low, okay? It's low, right? So you are able to get that. So probably we can put another else if here, so that we again put another level, probably high. Let us just put another level here called high. I've just copied pasted, if you are wondering what I did, and now I'm changing these values, that now it is more than 300 but less than probably 330, or just let's put 330 here, so that we don't waste time. We don't have time is over, and we just need to, if more than 330, then we don't need this, because already we have said it's more than 330. So if it is more than 330 or more than 300, because do we really need even to put more than 330? Yeah, it is more than 300, because already we have talked about 300 up there. Yes. So what is the water level? The water level is high. So let us see whether this will work. And delay 2000, we can put 1000. Let us just reduce. Let it be coming per second, 1 second, not 2 seconds. So if we save, we verify. Let us verify our code. Yes, it's good. It's perfect. Then how? Let us now. Great. And now let us check the monitor. Remember, we are looking at the monitor. The water level is high. Our water level is high. Now, it's low because I've removed a bit. Now, because I've removed it completely, now water level is empty. When I add, I just put a little high. Low and high. Remember, we only had two conditions, either low, high, or empty. So when it is not in the water or outside, or when there's no water like that, it's now empty. The water is empty. We put inside, it is low. When it's more deeper, the water level is high, and therefore turn off. It can, now we can even say, after, when it is high, turn off the tap or do something like that. Great. I think today we've learned a lot about water sensor, and you can see it can really monitor the amount of water used in each household. It can do a lot of things, and as you have seen, definitely you just tweak the code a bit, and you have a different thing altogether. And remember, we are trying to make code look as simple as possible, so that you are able to understand. And there's nothing very difficult about our code. You can read it and get the meaning. Unless there's any question, kindly keep asking questions. We leave these things very active. We leave the links active. You can come back at any time and be able to watch this video at your own time with the same link. And at the same time, you can be able to ask questions, and you'll be able to get them as we move back, because whatever question you ask will be given the attention it deserves. Thank you so much for today's. Let us again meet in our next session, where probably we'll be looking at more of your program or your project. We'd wish to do your project, so that we don't do our projects only, but you want to see what can we do with your project, the ones you are coming up with. What can we now start helping you bringing the materials together? We want to see you people collecting stuff and trying to start coding on your own, and seeing whether you can be able to master some of these things. Great. Thank you so much. Be blessed, and good evening, and have a nice weekend. God bless.